Alright, this is going to be a demonstration of the throttle control with the PLC as compared to the manual functions as I have here in the engineer control panel. As I've stated in previous videos, my house isn't level, so there are certain parts of this layout that are downhill and there are certain sections that are an uphill. I mean, right now the blue D&H is parked in the Thruway West, which is actually a downgrade, and then the main line south is somewhat of a downgrade and then transitions to an upgrade as it goes into the Thruway East and the team track, which is where the yellow Erie Lackawanna is parked right now, and the main line north is also a slight upgrade. So originally with the layout around my wall, I built this compensation box, which just has series of diodes back to back, and it's selectable with a rotary switch. 0 would be just the straight power through, so it's track power in all sections. And then as I turn the knob, it adds on more and more back-to-back diodes, dropping the voltage by 1.4 volts for each step. And the reduced track power would be in the Thruway West and in the mainline south, and then it changes back to full track power in the Thruway East and in the mainline north. So to give a demonstration, I have the unit right now in manual mode. Throttle control is set at approximately 70, which is relative. I have the compensation box off, so it's going to be straight track power. So I'm going to energize the main line, which starts up the blue D&H. And this is just going to show how the speed of the train changes as it passes through the different upgrades and downgrades. Now it's starting its upgrade. As you can see, it loses speed. And as it goes around the corner, which actually adds resistance, it loses a little more. And then it picks up speed. It's not so dramatic right here. It usually really depends on how much track power is applied. But say, for example, I'm going to turn the compensation box onto 2, which will now drop the track voltage by 2.8 volts. And you'll see the difference. So now as the train is entering the Thruway West, it enters a reduced voltage. And as it passes through the main line south, it resumes normal voltage. So as you can see, between the Thruway West and East, it's relatively smooth. But where the problem occurs, and this also is around my wall layout, is as it makes the bend to go into the mainline north. There's a considerable amount of speed loss because of the resistance of the train rounding the curve. So that was the best I was able to do with the around the wall layout in this compensation box. But now with PLC control, I can not only fine-tune that more, I can actually increase the throttle in different areas. So first, I'm going to stop the train in the Thruway West and stop manual mode. Now I'm going to go to automatic mode, and I'm going to start the train up. Right now it's just going to, it's set for 70% throttle. And one thing to notice is the offsets are disabled while it's doing a forward reverse operation. So hopefully the goofy blue D&H properly switches to forward mode so we can actually do this demonstration. Yeah, and of course, it's not moving. Hang on. Yeah, of course, the old goofy guy's got to mess up. Now getting a warning that the forward reverse routine on the main line is taking too long. There we go. Okay. So, first thing to do is I'm going to turn the whistle off. To simulate approximately the amount of throttle that I had. Well, first I'm going to turn the throttle off. Is about 50%. And let me turn off the offsets. So right now it's going to be about the same throttle power all through the track. So again, this is going to be like straight power. No change. No change in throttle as it goes through the different blocks. So the throttle's actually a little bit lower than it was in manual mode. So you'll get to see how with just the throttle set at 50% and no offsets, how the train behaves. Really starts to struggle going up the thruway east. And then you're really going to see a slowdown as it approaches the main line north because of the curve. And then as it starts to downgrade, it'll pick up speed. Yes, as the train does pass through curves, it does add resistance, which slows it down. Okay. So now, as you can see, the difference between the way I was able to control it manually, it was only allowable in large blocks. I can control it with all the 10 blocks. Well, actually 8 of them are part of the main line. So we'll turn on the offsets, because now what it can do, it not only can reduce the throttle power in downgrades, as you can see here, 5% lower, but it can actually increase the throttle as it approaches upgrades. This way it should further make the train run a little smoother. So let's have a look how she runs. Try to get the whole layout in place. So the throttle is reduced in this area. And then as it's rounding here, it's slowly brought back up to 0 or 50%. And then it will actually be increased by 5% to 55%. And as you can see, the train runs a lot more consistently through the blocks now, because I not only can reduce the track power in downgrades, I can actually increase the throttle in upgrades. Now, how much compensation and so forth is needed all really depends on the locomotives that are being run on the layout. So that's why I have a couple preset recipes on the touch panel. And then, of course, I can make fine adjustments as I see fit. Obviously, at a lower throttle, this is more dramatic than if I was running at a higher throttle, because, of course, the motors are running faster. So this is just a neat little demonstration of the analog control of the throttle control utilizing the PLC on the layout.